Before I move on, let me just mention on this previous problem about the snowball, what I should have done first is went ahead and differentiated for you. And then when you got to this point, you would have seen that you would have also you would have had to have the radius. So then you would have been prompted to go over here and plug the volume into this formula to get the corresponding radius. So I probably should have done that first, and then went over here and got the radius, and so to show you what you would plug back in for the radius in the formula. All right, let's take a look at another. This is a fairly common example. Here we have a ladder that's 20 feet long, leaning against a vertical building. So here's your ladder right here. And let's say the bottom of the ladder is going to start sliding away from the building. And we're going to tell you that it's sliding away at a rate of 2 feet per second. And so the question wants to know, how fast is the ladder sliding down the building? In other words, how fast is this rate changing? I'm going to call this height y. So at what rate is this y changing if this x changes at a rate of 2 feet per second? Okay, so let's go ahead and see what we know here. We know no matter where this ladder is in its slide, we know from Pythagorean theorem, x squared plus y squared has to equal 20 squared. So that's the first equation I'll start with. And I showed you how to differentiate these types earlier. If you differentiate this with respect to time, you'll get 2x times dx over dt, 2y times dy over dt, and of course the derivative of the constant is 0. I went ahead and divided everything by 2 here just to make the formula a little bit easier to follow. And you certainly can do that because the 2's will cancel here, and 0 divided by 2 is 0. So this is the same, basically the same equation. All right, now I know that dx over dt is 2. Now let me mention here, it's positive 2. And the reason I know it's positive is because x is getting bigger. This x, as the ladder slides, the x is getting very big. Now on the flip side of that, when you talk about the rate that y is changing, now y should be a negative answer. I mean, not y, but the change in y with respect to time should be a negative because y is actually getting smaller. Y is going to be decreasing. So just keep that in mind. Okay, so we know that dx over dt is 2. That's the rate the x is changing. We don't know the rate y is changing. We know, if you look at the question, it says it wants to know how fast is the ladder sliding down the building when the top of the ladder is 12 feet above the ground. So it wants to know what's happening when y equal 12. So we're given y is 12. Okay, well, you know when y is 12 and z is 20, you can use the Pythagorean theorem to get x. So if you're wondering where I got this x value of 16, I just used my old formula, x squared plus 12 squared equal 20 squared. And then I solved it for x. Okay, and then when I solved it, I got x equal 16. So that's where that came from. Okay, so now go back to this formula up here. Replace x with 16. We know dx over dt is 2. We know y is given to be 12. And then dy over dt is the unknown. Well, now that's 32. Subtract 32, and you get minus 32 on the other side. Then divide the 12 into minus 32, and you actually get a negative 32 divided by 12 is negative 2.67. So that's a negative 2.67 feet per second is the rate that the ladder is sliding down the building. Okay, here's another example. How rapidly will the fluid level inside a vertical cylindrical tank of radius 5 feet drop if we pump the fluid out at a rate of 100 cubic inches per second. Okay, now one thing you must remember is that the radius of this tank is 5 feet. So from here to here is 5 feet. But remember, 5 feet is 60 inches. So keep that in mind. Now, what are we given? We know the volume is changing at a rate of negative 100 cubic inches per second. And we're asked to find the rate that the height is changing. Okay, so now let me show you basically the height of the fluid would be, say, right in here. And so we're wanting to know what the rate of the height is changing, or what rate is this height changing. So we need a relationship between the volume and the height. And that's where the formula for the volume of a cylinder comes in. We know the volume of a cylinder is pi r squared times h. But we know the radius is never going to change. It's going to be a constant at 60 inches. So I can plug 60 in for the radius. Now I can't do that for the height, because remember, the height's going to be changing as the water drains, or the liquid drains, but the radius is not going to change. So pi times 60 squared will be 3600 pi. So the volume would be 3600 pi times h. Now, if I take the derivative of this with respect to t, on the left I get dv dt, and on the right I get the derivative of 3600 pi h. Well, 3600 pi is just a constant, so I just have to figure out what's the derivative of h with respect to t, and the derivative of h with respect to t is just that, the derivative of h with respect to t. So I have 3600 pi times dh over dt. Now, all I have to do is plug in my known. There's only one known value to plug in, and that's the change in the volume with respect to time, and that's negative 100. And then I take that negative 100, divide by 3600 pi, and it will give me the change in height with respect to t right here. And then I went ahead and put it in the calculator, and I got negative 0.0088 inches per second. Which makes sense that it would be negative, because obviously if the liquid is draining, then the height of the fluid would be dropping or decreasing. Okay, on this one, freeze the video and read it if you need to first, but basically what we've got is we've got a starting point here, and we've got a convoy heading north, so we got a convoy heading this direction, and then we got a convoy heading east this direction, and we know that this convoy is traveling 30 miles per hour, this convoy is traveling 40 miles per hour. And as these two convoys travel, we know that not only is the distance y, the distance from the starting point that this convoy reaches, is changing, and the distance that this convoy reaches is changing, but also the distance z between them is changing. So unlike the latter problem, here the hypotenuse is actually changing as well. So the relationship between x, y, and z could be satisfied with this Pythagorean theorem here, x squared plus y squared equals z squared. And then I could differentiate each of these. And you saw me do this earlier, so let me just go ahead and drop down to this step. And I got 2x times dx dt plus 2y times dy dt plus 2z times dz dt. Now, divide everything by 2, and you get this. Now, let's talk about what we know. We know that dx dt is 40, because that's the rate that the convoy is traveling to the east. We know dy over dt is 30. That's the rate they're traveling north. That was given. Okay, so we know that we can plug 40 in for dx dt, and we can plug 30 in for dy dt. Now, if you just use common sense, because it's asking at 6 minutes. Well, 6 minutes is 1/10 of an hour. So at 1/10 of an hour, if you think about it, 1/10 of an hour, if this convoy is traveling 30 miles per hour, then 1/10 of an hour, it will have gone 3 miles. And if this convoy is traveling 40 miles per hour, then in 1/10 of an hour, it will have gone 4 miles. So y would be 3 and x would be 4, and then applying the Pythagorean theorem, when y is 3 and x is 4, you would get z is 5, because 3 squared plus 4 squared has to equal 5 squared. And so now we know we know x, y, and z, and so now we can plug in x here, we can plug in y here, we can plug in z here, and now we're trying to figure out the rate between the convoys is changing, dz over dt. So we have 4 times 40 is 160, plus 90 would be 250, and then so you have 250 equals 5 dz dt, and then divide by 5, and you get that the rate that z is changing with respect to time is 50 miles per hour. Okay, so here we've got a tank that's shaped like a cone and water is pouring into it. And what we want to do is we want to find how fast the water level is rising. That would be, you know, this H right here. If this is the water level, how fast is the water rising when the water reaches 6 feet deep? Well, something you can do here, they tell us that the radius of this tank at the top is 5 and the height is 10. Well, you can use similar triangles, and that way you can get a relationship between the radius and the height when the water reaches any particular level. So if we let r be the radius when the water level is here and height be the height when the water level is there, then we know that 5 over 10 has to equal r over h using similar triangles. And then you can cross multiply that and get 10r equals 5h, and then solve for r, and you get r equals 1/2 h. Now that's important because we needed r in terms of h. And the reason is the volume of a cone is 1/3 pi r squared h. So I need to eliminate this r. I can replace r with 1/2 h. And then when I simplify that, you can do this algebra here on your own, but you square this and then multiply it out, and you actually get the volume is 1/12 pi h cubed. Now, if I differentiate, you know, if you differentiate the left, you get dv over dt. If you differentiate this part, you're going to get 3 pi h squared times dh dt, and the 3 over 12 is going to be 1/4. So you're going to get 1/4 pi h squared times dh dt. Now, we know the rest of it because we know the water is going into the tank at a rate of 9 cubic feet per minute. So we've got that given. So the change in volume with respect to time is 9. We know the height of the tank is 6. That because it says we want to know the how fast is the water level, or how fast is the water level rising when the water is 6. So we know the height is 6. So we can plug 6 in for that. And then 1/4 times pi times 36 is going to give me 9 pi. And then I'm going to solve for dh dt. So I have 9 equal 9 pi dh dt. So divide both sides by 9 pi. Well, 9 over 9 pi is simply 1 divided by pi, which is 0.318, and the units would be feet per minute. So about 0.32 feet per minute. You can actually be given formulas that you have, like in this problem, go ahead and freeze the video and read it if you need to, but this says volume is equal to I, or voltage is equal to IR. I is the current, R is the resistance. And so what I want to do is, it says if the current in the electrical system is decreasing at a rate of 5 amps per second while the voltage remains constant at 16 volts, at what rate is the resistance increasing when the current is 28 amps? Well, let me just summarize what I did. Since V is constant, I can say IR equals 16, and then I have to use the product rule to get this, differentiating. The problem tells me that I is 28. It tells me that di over dt is -5. But then I have to use V equal IR to solve for R, so I can get R as 4/7. And then after that, I can solve for dr over dt just by solving this equation. And eventually I get dr over dt is 4/49. So it's 4/49 ohms per second.